So review video, let's see, 29. What we're looking at is we need, let's see, a pair of triangles that can be proved congruent, given that what we have is a parallelogram. So there's several options here. What we could go with is this one. Let me highlight these. We could go with these triangles right here. All right, and we'll get, let's see. So I think we can get triangle CDF congruent to triangle ABE. Now, how I would do that, the method of congruence, I would get these opposite sides congruent. Okay, so CD is going to be congruent to AB. I'm not going to write the whole proof, so that gets me a pair of sides. Now, because these are parallel as well, we're going to get that those angles are congruent by alternate interior angles theorem. So what we get is angle DCF congruent to angle BAE. Of course, that gets us a pair of angles. And then our pair of sides is already marked. So a pair of sides that are already marked is CF congruent to AE. And that gives us a proof by side angle side. Triangle congruence theorem. All right, it's not a full-on proof, so that's more than enough right there. Okay, we're given that it's a parallelogram. So the one that's not. Okay, so what I'll do is, this is one option. So we'll get this bow tie going here. What I'm going to get is, these are parallel sides. So that's going to give me this angle here and this angle there by alternate interior angles. We can get vertical angles, and then of course, yeah. All right, so almost didn't have it, but AB, this whole thing is going to be congruent to CD. So their halves are going to be congruent. So technically I could throw this as, so as a result, those halves are the same. So CM is going to be congruent to AN. That's going to get us our pair of sides. So we're going to say triangle CMO is congruent to triangle ANO by the, it's going to be angle, side, triangle congruence theorem. Okay. Next one. A lot happening on this problem. There's a couple ways we could go about this. What I noticed was, since this is a parallelogram, what you have is these sides parallel. Okay, now using the alternate interior angles, right, we'll call this angle 1 and this angle 2. Those two angles are the same, so these two sides are the same. Okay. Same thing's happening over here. If you look at this, you've got the alternate interior angles here with here, 3 with 4. You know, if we number them, it's a little easier to talk about them. So let's use that. Actually, I could renumber them here. I would actually call this one 1. Okay, and probably go 4, 5, and 6 maybe over here. Okay, so I don't have to do the 3-letter path on all of those. All right, what's going to happen is, let's get back to it. So these two sides are going to be the same because it's isosceles. Now, this side is the same as this side because of opposite sides of a parallelogram are congruent. This is isosceles, so these are the same. And what we have is, finally, those are congruent because opposite angles in a parallelogram are congruent. So you have side angle, side again. There's probably quicker ways, easier ways to do that, but that's what I'm going to end up doing. All right. So I would get triangle ADE is congruent to triangle CBF. Okay, by the side angle side triangle congruence theorem. Now I'll run through that again. That was a lot. Okay, so I numbered them. All right, what we're going to say is angle 1 is congruent to angle 2. Sorry. That looked like it was given, actually. Looks like it was given. Angle 2, no, angle 1 is congruent to angle 3 by alternate interior angles theorem. Remember, this is not a full proof. If it was a full proof, I'd have to mention that those are parallel, DC and AB. I'm just trying to summarize what I did. So then, because of these two things, angle 2 is congruent to angle 3. That's by transitive property or substitution. And then that makes triangle ADE isosceles. Okay, that's where we get these two the same from, and then it just kind of continues from there. I'm not going to go through the rest of it. You heard that in the beginning, but I wanted to really clarify a little bit, how did I actually get these two sides the same? Okay, so that was what that was for. All right, with these, we'll go through these proofs. Really, enough practice if you do a couple of them. I'll do them all, but if you do, say, 3 of those, I was looking at 1, and I really like 1, 5, and even 7. So 1, 5, and 7 would probably be enough practice. But if you have time to try more, go ahead. So this is number 32. There's 8 proofs on this. That's way more than what we need, but I'll go through them and we'll see how we do. So these are synthetic proofs made up. They're telling us it's a rhombus, and we want to prove angle 1 is congruent to angle 2. So what rhombus is going to give us is all these sides the same. Now, they're telling us AC is also the same as BC. What you're going to notice is now we have over here, if you highlight this triangle, it's now isosceles because of those two sides being the same. That's going to get us angles 1 and 2 the same. So that's what we're going to do. So let's go through that. Let's see. I'm going to start with AC congruent to BC because it's given. Okay. Second thing, ACEF is a rhombus, also because it is given. And next, what we have is, let's see, AC is going to also be congruent to EC. Now, I could have said all the sides, but I don't need them. You know, I just need these two. So all sides of a rhombus are congruent. You could say anything. A rhombus is equilateral, something like that. Okay. So now what we have is EC is congruent to BC. That's because if you see these two, right? AC is congruent to BC and AC is congruent to EC, so they're congruent to each other. It's transitive property, or we say, we usually just learn less of those kinds of things, less theorems. What it is substitution is the easy way to get away with this. It covers a couple different ones. And now triangle CEB. This is kind of an extra step. You might not need it. You probably could have jumped right to what I'm going to say next. 6, angle 1 is congruent to angle 2 by base angles theorem. That is, base angles of an isosceles triangle are congruent. So you probably could have skipped 5, but I'll just put it in there. All right, I'm going to do a few more on the next video.